Good morning, good afternoon. Thank you everybody for joining our webinar today on Fireless attacks and how to stop them. My name is Brian Robinson. I'm the Chief Evangelist here at BlackBerry Cylance, and I would love to welcome you all to today's webinar. Let's go ahead and get started on the content. I think today is going to be kind of fun. I've got a couple of different things that we're going to take a look at, and as always, if anybody has attended any of my and Stuart McClure's Hacking Exposed or any of my other webinars that I do, I spend as little time as possible in slides and spend most time looking at technology and doing things live on the screen. One word of warning, as always, we are messing with live attacks today. So things that happen on the screen may happen that aren't planned or have not, occurred during rehearsals or anything else. So please bear with us if we have any issues that happen. All right, so let's just go ahead and move in. Today, our agenda, it's pretty simple. We're going to basically just have, I think I only have maybe 2 slides. What is a fileless attack and why do they matter? And then we're going to jump in and actually do hands-on playtime. And I think this is one of the reasons why a lot of you come to my webinars is I spend most time actually showing these techniques and how they will in your environment, rather than just a talking head lecturing to you about the importance of these attacks and what they are and things like that. So as always, I love to get my hands dirty, and that's where we're going to spend the majority of the time today. So once again, if you have questions, for those of you who just joined in, if you have questions, please do enter those in the QA widget at the bottom of the screen. I will attempt to get to them as fast as possible. And yes, I do see the typo on the screen where I forgot my question mark. I'm sorry about that. Okay, so quick agenda. That's what we're going to do today. It's going to be very basic. Like I said, we're going to spend just another minute or 2 here in the slides, and then we're going to go play because I think that's where we're going to learn the most. What are fileless attacks, and why do we keep hearing about them in the news? What are they? How are they different from, kind of a traditional malware-based attack? Well, really simply, they kind of fall into 4 major categories, whether they're memory resident, script-based, they exploit resources, or they attack the system registry. But the main goal here with a fileless attack, different from a traditional kind of malware attack, is that the initial vector of the attack is not an executable file. It's not an exe, it's not a DLL. It's usually a script, it's usually something that runs and it's designed to bypass a lot of the evasion or the detection technologies that are out there. Initially, it also doesn't necessarily write files to disk, so it's not going to trigger a lot of the traditional detection methods, especially traditional AV, because it's looking for file writes and file reads and things like that. So those types of behaviors are kind of what define the world of the fileless attack. Again, they're used mainly in the initial phases of the attack. So at some point, the attacker is going to have to execute code on your machine to do something, to take over a process or to do something. So sometimes that can happen in a script, and sometimes it's going to need some sort of executable or something like that. Or their goal is to gain command and control and then to download some malware and ransom your system or something like that. But that's the end phase. So the exe that gets downloaded from their C2 and gets executed, that's usually at the very end after they've done all their recon and things like that. So at least in the initial phases of the attack, there are not executable files being used. Now, that's not to say that these attacks don't ever come from a, quote, file. The most popular type of file that these attacks begin from is actually a malicious document of some sort, PDF, Word doc, Excel, PowerPoint, whatever it is. It's usually a weaponized document. So to call it a completely fileless type of an attack is not really true. It starts from a file in most cases, but that file is simply not an executable file, which we can block with just about any basic technology, blacklisting, whitelisting, even stuff like that. Now, sometimes there are what we kind of see as zero-day exploit-based types of attacks. Now, these attacks are going to attack potentially an exploit that is publicly facing, let's say, right? So let's say, you go back to cross-site scripting or SQL injection, right? A specially crafted string sent to a web server could cause an exploit to happen and then give that user some ability to access the system. But those types of attacks like that are somewhat rare. And generally, I mean, the vast majority of these, quote, fileless attacks traditionally start from a file, but it's usually a weaponized document and definitely not an executable or something that's going to cause your AV engine to scan. Now, the other thing is I also say that generally these are designed to live off the land. So the reason fileless attacks are successful and work is that there are a lot of very powerful tools on our workstations these days and on our servers that these attackers can use without having to put their own technology down on that box. So the less they have to put on that box, the chances of detection go down even more. So the less they have to change or the less they have to bring down to the system and execute in memory, things like that, the less chances of attack detection. So they're going to try to use live off the land techniques. They're going to use PowerShell. They're going to use CertUtil. They're going to use tools that exist on the systems that are generally already trusted by the system. And that's essentially how these succeed. Okay. So very, very, very quickly, we're going to look at some statistics and basically try to say, okay, why do these attacks matter? So in a recent survey, 54% of the companies surveyed experienced a compromised, and 77% of those who experienced a compromise were basically resulted in use of a fileless technique. So rather than USB droppers with EXEs on them or just emailing EXEs, which all of you know doesn't really work anymore, most of these people were actually attacked successfully with fileless techniques. So as a result, we're seeing the incidence of fileless attacks rising significantly over the past year or two. To me, and kind of a shameless plug here for Cylance, I think that a lot of this is due to essentially the effectiveness of tools like Cylance that can actually predict and prevent malicious files from being executed. And so we see the incidence of file-based attacks declining because of the effectiveness of tools like Cylance's pre-execution using machine learning that actually can, prevent better than 99% of unknown files that are bad from executing. So yes, there are still hundreds and hundreds of thousands of samples of malware created on a daily basis, traditional executable malware. The problem is with technology that exists today, like Cylance, the effectiveness of those EXEs is a lot less. So obviously attackers are moving into different realms, and one of those is fileless techniques. Okay, a couple of notable examples, recent examples, and how we're going to actually kind of tee up the demos we're going to do today. We're mainly going to be looking at APT32 techniques today, and we're going to actually go through and reproduce some of these techniques. Now, for any of those of you who have watched the Hacking Exposed webinars or got a chance to see us live at RSA this year, one of the things that I do with these attacks is when we see them and we investigate them, we've been called into companies to stop a compromise or something like that, or clean up after an incident, is we reverse engineer kind of those attacks and how they got in and what the initial vectors were and things like that. And then I try to recreate those into tools that we can all use on a daily basis, not just for our own education, but also to test the effectiveness of our tools and techniques to defend against those types of attacks. So the tools and techniques and things today that I'm going to show you are based on the techniques of APT32, also called Ocean Lotus. And we're going to take a look at a couple of different things. Pretty much they're all kind of script-based attacks, but there's different ways to launch them in which the code and the stuff that's running never actually gets staved out to disk. It always gets executed directly into memory. And that allows us to participate in a kind of a non-detectable type of environment. So we're going to take a look at using a couple of friends that I've used before. We're going to look at IQY files and DDE. And I'll talk about DDE when we get to that demo. And then on the third demo, we're going to actually go create and deliver a command and control infrastructure using a crafted malicious document based upon APT32's techniques. And the cool thing about that document is you can actually build it cross-platform. It can work on Mac and PC. So it's a lot of fun. Okay, it is time to play. So let's just go ahead and jump right in. And again, questions, if you have them, please do enter them in the Q&A widget at the bottom of the screen, and I will try to get to them throughout this demonstration. I've got a couple of victim systems, and we want to start with our third victim system here. Okay, so our victim systems are just a standard Windows 10. These are 1809s, Enterprise Edition, and we've got some of these, just files sitting out here on the desktop. For example, you can see my cows here chewing on a pallet. There's just some files sitting here. And the reason I have these files sitting out here is to basically simulate kind of a real world desktop. You've got some work documents, you've got some PDF documents on here, you've got all kinds of fun things. You've got Office installed, PDF document. So this way we can kind of see, as some of these attacks, we're actually going to deliver some malware and try to destroy the system, again, after we get a certain distance through the attack. So the first example we're going to take a look at is a file type called IQY. Now, an IQY file, and again, this is something that is still being used, but a lot of users are pretty darn familiar with things like how to work with attachments. They see XLS attachments or zip file attachments or things like that all the time. Now, this interesting one that came out last year is called IQY. And so basically attached to the email is an IQY file. So we're going to download this, and then we're going to open this in a folder. The reason this file is interesting is that it is a Microsoft Excel file, but it's an older file designed to query the web or a data service directly and pull data into the Excel file. And it hasn't really been used in a long time. So basically, when APT32 began using this, a lot of the users in the world essentially weren't understanding what an IQY file was. So it looked kind of normal to them. Now, the cool thing is, we'll open this with Notepad. If you statically examine this file, this is all that is in it. It's really kind of creepy in that, let's say you've got a gateway-based, AV product or something, but instead of delivering the malware or the attack directly in the actual file coming through your gateway, Fireless attacks utilize the ability to hide things and come through the gateway without really anything malicious in the file itself. So again, this is the only thing that's in this file. It basically is the URL that's going to open up when Excel executes this thing. It's going to open up this file, this URL, and download this file. So first thing we're going to do, I want to go show you what this file looks like. So what this file that it's going to download is actually a field that's going to enter and execute a command shell directly in Microsoft Excel, but it's going to be a PowerShell command, and it's going to download essentially from the same site. It's then going to go download this file called one.dat. Now, I've left this command in clear text so that you can kind of see what's happening here. But it's also very easy to do this with a Base64 encoded command or something like that to obfuscate it, so that as it transits firewalls and scanners and next-gen tools that are looking at the content, it's very, very easy to hide this from view. And we're actually going to take a look at some of those techniques in the third demo. So one.dat is essentially going to come in and it's going to download one.dat. So 2.dat comes in first, and then it downloads one.dat. One.dat is actually where the magic kind of happens. So basically, we set a variable here, and we're going to go. This one is not necessarily a great example of fileless, but at least in the initial vector, it's all completely quote fileless. So with this one, it's going to be very simple. We're just going to execute this PowerShell command that goes and downloads this file. And then this one executes, and it's going to simply download this exe and execute it. So let's go ahead and take a look at this one, how it works when it runs. I've always liked this one because of the fact that this IQY file, a lot of people don't really understand what this is. And it's not going to pop up the normal kind of yellow warning bar, enable macros kind of thing that a lot of our users have been trained on. So there are several different techniques. In the 3 different demos today, I'm going to show you 3 different Microsoft error messages that your users might not ever really recognize. And that's kind of the key of this attack as well. So you obviously do get a warning that pops up. The thing is it's not really the traditional warning that user might expect. So, if the social engineering is done well, where they, basically say, hey, this is okay, you can click on this, or if they send it from a trusted source. I mean, how many people today click on the enable macros even though they know they're not supposed to? So if you can trick up that situation a little bit, then you can actually get users to click on these things more often. So obviously data connections are disabled, but we're going to go ahead and enable them. It's downloaded the first command and it's now actually going to execute the second command. So as you can see, this is really just kind of the entire Excel file is just in this one field, but you can see it went and grabbed this and it downloaded it. But again, there's nothing malicious even in this command that could be picked up. The actual magic happens when this file gets downloaded and executed in the background. So it's basically happened, and if we close Excel, yeah, it can't find the file anymore because that bad news for you file was actually WannaCry that got downloaded and encrypted this system. So, this is a good example of delivering a very bad payload, aka WannaCry, with an initial vector that is completely fileless. There's no executable malware. There's, all that good stuff that we would normally be able to detect is simply not there. So WannaCry is going to be busy doing its thing, but we're going to put it out of its misery and we're going to recycle this system back to the demo gods and let it reset. So while that happens, we are going to flip into our second demo. Again, if there's any questions for folks, please do enter them in the Q&A. Okay, so the second example, we're actually going to, once again, our goal with Fireless attacks is really to exploit the user, right? We're trying to get them to do something that they normally wouldn't do. And a lot of that is going to be around social engineering on a specific thing. So in this example, what we're going to do, we're going to take this resume document sitting out here on the desktop, and we're going to open it. And this document actually does have a macro in it. We've used this document before in previous webinars, so you've probably seen this before. But what it does is this gives you your standard end user warning. However, we just click enable content. And in this document, it's actually a legitimate macro that simply updates the fields in the document based upon your Active Directory login name. So this is an example of a good use of a macro, and is also an example of why you can't just simply disable macros in a lot of business environments that do use legitimate purpose macros. We're going to use this document a little bit in the next couple of demos, and this is kind of be fun. But in this example, we're going to take a look at something called DDE, and that is basically an old Microsoft feature that still exists that allows you to dynamically link data into your documents from public sources. Now, Microsoft did release Microsoft Office fix that disabled DDE across all of the Office platforms. However, based upon feedback, because it destroyed customers' data and their documents and everything else, they issued another patch which only disables it in Microsoft Word. So it's still active in Outlook, it's still active in Excel, it's still active in PowerPoint, etc. And then I have, in this system, I've actually turned it off again for Word, but that's just so that we can do this type of demo. So again, it's something that, if you want to turn this off across your entire organization, you can't rely on the simple Microsoft patch. You're going to have to actually turn this off with registry keys that are deployed through group policy or something like that. So to use this one's kind of fun. But again, the reason I like to show this one is because of what we can do with the actual error message. So what I want to do is I'm just going to come down here and I'm going to just replace this period right here at the end of this sentence, this word sentences. I'm going to replace this and I'm going to put in this field. We're just going to put in an empty field. Now, this field, we can delete the majority of this text here. And so basically, if you look at this document, now they just have an exclamation point in here. However, if you hover over the exclamation point, you'll see the very, very tiny gray field in there. And now we can toggle the field codes to actually get into the actual code that's in this field. Now, I've created this already for us. This is kind of interesting, and I love using this one because it's kind of a fun example of how this works. So the first thing we're going to do is we're going to put in the word DDE auto, and that's a keyword that allows us to execute this. And again, we're simply going to execute a PowerShell command, but this time we're going to actually go download a PS1 script to our command and control server and execute it directly into memory. So we're not going to download the PS1 file to disk and execute it. We're going to execute it directly in memory. So we're going to use, and the part that's missing is the ability to actually modify and change the error message that pops up on the screen. Now, most attacks, you have to deal with Microsoft's error messages, but this one has a very specific way of invoking it. For example, we can put in some text up here at the front that makes it look more legit in the fake path. This is actually a fake path, but to the user, it's going to look legitimate. And then we have this word down here at the bottom called blah, and we can simply replace this with allowed by your security department, okay? Now, the reason I'm going to do that is because this text is actually going to be popped up into the error message that is going to come up from this document. And this is the scary part of this. So all we're going to do is simply save the document, and we're going to reopen it. And you're going to get, these kind of warnings, right? Document contains links that refer to other files, but this again is very common. So you click yes. And in this case, you see the remote data, and you can see the actual message that you typed in, allowed by your security department, is not accessible. Do you want to start the application? And then you can see that fake path that I typed in. And now there's a certain amount of characters you can type here and a certain amount of things, but if you spend a little time with this and play with it, you can actually create a situation where you've actually created something that looks like an acceptable error message. So specially crafted social engineered email along with some specially crafted social engineered Microsoft Word error dialogues, again, raise the chances of your victim potentially executing this file. Now, so we've got our command and control sitting back here in the background, and I'm going to go ahead and start this up so you can kind of see what happens. The first thing we need to do is we need a simple Python web server here. This is going to serve up the initial PS1 file for our malware to go download, or for our attack to go download. And then we're going to have our Python command and control here listening for a connection back. Okay, so if this attack runs, what you should see is it'll download the file, the PS1 file from here, and then you'll see a callback and a successful connection back into the Trevor C2 command and control on this screen. Now, the interesting thing is, and sometimes this works and sometimes this doesn't, but even if the user doesn't like this error message and they hit no, I have seen several times where this actually works and the command actually gets executed. So we're going to try it anyway. So if the user hits no, and then they hit OK, they hit no, and they hit OK. Yeah, it didn't work this time, but I have seen this actually work. Okay, so we're going to close that and we'll reopen it. Sorry about that. Like I said, I've seen sometimes where even hitting no causes that to actually happen. So we're gonna proceed. So we're gonna click yes, and this time we're gonna hit yes because again, it's allowed by our security department. Did I screw things up? Oh, no, it actually did work the first time, darn it. So it actually did work the first time when I hit no. I just had my scroll stopped on my SSH shell, so we didn't actually see it happen. I want to do that again so you can see that. I apologize, but this is kind of critical, and I love seeing this actually happen. A good indicator for this one is that there probably is going to be PowerShell running in the background. Yeah, we actually have 2 shells because we actually successfully executed it. All right. And I'll say yes to this field here, but we're going to say, I don't like this. I don't trust this. I want to ask somebody about it. I want to hit no. Okay. No. Okay. Oh. Is it going to work? Maybe not. Did I screw it up again? No. Okay. I must have done something wrong. So we'll go back to the yeses. I'm sorry, guys. It must have been a yes. Like I said, I have seen this work before where you do hit the no and it does actually connect, but we actually got it connected twice here. So, so we see it downloaded. We can interact with the session. We actually have a connection to our victim system here, and we can begin using our remote command and control to do things like task kill im winword.exe force, so we can actually send and communicate with the endpoint. So this is a good example of being able to get past a lot of your user training with specially crafted error messages that our users are normally not going to ignore. We'll have a higher chance of getting in through our attack with that type of method. Okay, so the third demo, this one I think you guys are going to like. This one's a little bit fun. And first thing we're going to do is we're going to open up some tools here to keep an eye on some things. So we're going to need that. And let's see, I need to get back over here because I'm not going to want this Trevor anymore. All right, and actually we're going to just recycle that one to the demo gods as well. Okay, so in this demo environment, what we're going to do is we're going to basically kind of do the same thing. We're going to SSH into our Kali box that has our Trevor client. Get our simple web server set up here. And then we'll get our C2 set up. All right. So that's the basic setup. Now, what we're going to do, we're going to minimize those and get those out of the way. So again, we're going to use our legitimate document that has a legitimate macro in it. But what we're going to do is we're actually going to replace that macro. And oh, cool. We have some questions. I just popped back. Yes. Yeah, I can put these files, make them available to you. At the end of the webinar today, I'm going to give you my direct email address and everything. So if you want these actual files, I have no problem sending them to you, including even this nasty VB script that we're going to just use here in a moment. So we'll have a little bit of fun with this. But yeah, this will allow you to test these things kind of in your own environment. Okay, so this one's kind of fun to follow. So let's take a look at this one. Again, we're going to enable the content because it just uses a macro to update our username into our macro. So it's very simple. This is all it does. And again, this is not a malicious macro in any way, shape, or form. It's just going to update those fields. So let's say with this file, our users in our company are expecting this to have the enable macro warning because it's general behavior for our environment. However, what we're going to do with this one, this is where things get a little bit fun. I don't know. I have a real weird, sick sense of humor, I guess. I think playing with things like this are fun. We're going to take this VBA code. Now, this is some VBA code that is based upon APT32 techniques. I have modified it substantially so that it actually does work better on both platforms. But basically, there's nothing malicious in this VBA code that can be picked up from a static scanning standpoint. Okay, it's difficult to determine if anything bad is going to happen with this because there's nothing in here that is really detectable in being executed. But basically what we're going to do here, you can see here this very, very simple if-else statement. What this does is it determines which platform it's running on. I showed this a little while ago, a few months ago, I guess, where we actually use this also to take command and control of a Mac system. But this is a true cross-platform VB script. And so today we're going to execute it on a PC. But what it's going to do is it's going to get the bad string from the company name in the properties field of the document. And it's going to be a Base64 encoded string. So it actually has its own Base64 decoder built directly into the macro. Now, this is one that we saw, again, APT32 using very successfully to attack targets in Asia. And so it makes life interesting. So what we're going to do is we are simply going to save this document because we're going to now create our string. So again, in the document, in the actual document file itself, there is actually nothing malicious. There's no PowerShell commands. There's not even a CMD exe. There's nothing there. So we're going to use the same kind of PowerShell command we used from before. And this is your standard, out of the box PowerShell command, PowerShell one-liner. This is like the most simple definition of a PowerShell one-liner command. You're going to download this file, a PS1, and you're going to execute it in memory. Now, the interesting thing is, and this is where we're going to go a little wild today. I'm sorry that I did not practice this, so this may or may not work. So what we're going to do is we're going to go download this PS1 by hand. All right. So we went to the web server and we downloaded the PS1. So here's the PS1 itself. Now, if we actually just go to a command shell, and like I said, this may or may not work. I hope it does. We should not be able to just simply execute the PS1 from the command line because we don't really have, oops, I'm sorry. My brain is not working. It needs the path. We should not be able to do this because the default execution rights on a Windows system disable the ability to just execute any untrusted PS1. So again, you simply just can't download the PS1 and double click on it and execute it because of the default execution rights. However, if you execute the PowerShell from Microsoft Word, for some reason, the execution policy doesn't apply. So this, again, is a technique that the attackers are using. There's a bunch of different ways to bypass that very simple execution policy on a Windows system. Now, what we're going to do, we're going to obfuscate this command because let's say, we are using a public URL in here, and if we put it in the document in clear text, let's say, an anti-spam gateway or something could see that URL and determine that it's a bad URL. and then not allow it. That kind of stuff happens all the time. So all we're going to do is use this tool called CyberChef. Very cool tool, by the way. Plus, you can download an offline version of it and keep it on your system. We're going to simply convert this string, this PowerShell command, into a nice little Base64 encoded string that doesn't really show up on any sort of scanner. Now we're going to take the output, we're going to copy that, and we are going to, we don't even have to open our resume anymore. We just are going to go into our properties field, and we can go into the details. And again, for PC, we paste the command into the company field. If it's a Mac, we paste the command into the comments field. So in fact, I actually have, this is the Python command here that you can run on a Mac to actually go download the Trevor client from the server. Now you have to put that command, Base64 encoded, into this command here that is called a wrapper, so that it can, you put that Base64 encoded code into here, and then you Base64 encode this entire string into a bigger thing, and then you paste that into the comments field of that document, and you'll have a Mac version that will actually execute the Python version of the Trevor client. So again, I don't have to open this document. This is weaponized right now. I could email it to somebody and they would be able to open it and actually have something very, very bad happen on their system. So in fact, because I have already saved this document with macros enabled, I think we're going to probably execute this upon load. And it's actually going to yield connection into our C2. So you can see here, we now have a connection into our C2. What we're going to do, we're actually going to stop that connection, and we're going to kill the PowerShell command running in memory, because I want to show you how this thing actually works. So it works. All I had to do was paste in that Base64 encoded command, and we got a command shell. But this is, I like showing this because this is the part where, you know, I get into the reverse engineering, and this is actually kind of fun to do. We're going to view the locals window, and this is going to allow us to watch the variables as they get created. All right, so now we're going to run debug, and we're going to step into the VB. Okay, so you can see there the highlighted text in the top. We're going to start stepping through the are we watching the right variables list here? Sorry, locals. We need locals, not watches. I'm sorry. Okay, so we come down here and we've actually got two variables created, found value and a real string. Right now they're empty. So when we execute this command, it's going to go pull the value from the document properties in the company field. So think about all those different fields where you could put commands and things like that. You can actually use your VB script to pull those commands in and execute them at runtime only. So we're going to continue stepping through. And so now you basically, here at the bottom, you can see the Base64 encoded string getting pulled in to memory and stored in that variable. Okay? So next, we're going to go and actually do a Base64 decoding. So it has its own little library in here, and it's going to just start kind of running through. So it pulls the string in, and then it's going to start running through this loop 173 times. Now, I'm just going to run through the loop a few times. You can see here it's just running through the loop, and it's Base64 encoding as it goes. And you can start seeing this variable here, which is S out, so string out. So string out, as you can see here, it's developing POW as we go through here. Now I'm going to hold down the key for a minute, and you'll see it just kind of churn through and start decoding that string. See how that's working? It's just going through, and it's just continually decoding that string. Now, that could take a very long time if it's a very long string. So what we're actually going to do is we're going to put a breakpoint right here in our VB script, and then we're going to hit one key to resume and let the computer finish decoding that string as fast as it can. So we're just going to hit run. Bang. Okay, so there, that's how fast it completed. And you can see it's reconverted that Base64 encoded string back to the actual PowerShell command. Okay, so now we're going to step. We're going to now take that value and we're going to bring it back and put it into the real string that we're then going to execute on the Windows system. So then again, we step again, we take that string down, and this is where we actually run this. And that completes the macro. And we should now have another Trevor connection down here on our screen. So once again, here we have a connection to a different victim system that is done with a malicious macro that is really highly obfuscated and is very easily bypassing, the different detection techniques that are out there. So the last thing I want to do is I want to just show how Cylance does with this, and then we're going to get to the questions. I see a few more have popped in. So we're going to take our resume, we're going to put it over here in our Dropbox. So the first thing we're going to take a look at is the IQY file, sorry. And we're going to download this file just like we did on our victim system. And we're going to bring it up. And just like on our victim system, this file basically, when you run it, it launched Microsoft Excel. And you're going to get your standard security warnings. So just like with our victim, we're going to go ahead and enable that. And then we're going to go ahead and execute, allow it to attempt to download. And very, very quickly, what we see here is we get a Cylance Optics detection. But more importantly, we actually see Microsoft Excel close in the background. And this is due to the active response capability that Cylance Optics has in its ability to actually automatically respond and do something on your behalf instead of just kind of uploading the different bits of information to the console and letting you have to try to make the decision. Cylance Optics is a preventative technology as well that allows you to actually set up a rule and respond immediately taking action on that asset depending on what rules you have set. So let's pop over and actually look in the console at what actually Optics saw during the execution of the IQY file. So we start at our dashboard and we look at our Cylance Optics detections that have occurred. And you're going to see a whole bunch of detections in here that are basically using the environment and detecting what's happening on the system. I mean, obviously there are multiple rules here that are being displayed. There is kind of this initial DDE rule that's displayed. We also get a machine learning hit with a one-liner command, which is also basically the PowerShell download command as well as the PowerShell malware kind of a rule hit. So these two rules, the Fireless PowerShell malware and the PowerShell download, are individual rules based upon the syntax of the commands trying to be attempted as an example. The machine learning module is a newer rule essentially that has been built into the system, and it's basically built in machine learning. So it's learned from millions and millions of different Fireless PowerShell commands, PowerShell download commands, etc. And we've actually built a rule using machine learning to actually allow Cylance Optics to respond with a rule based in AI rather than rules that are based upon, basically, syntax pattern matching or text pattern matching like Fireless PowerShell malware rules. So essentially the one-liner ML module rule can essentially replace these other individual rules, but I have them all turned on right now. So if we go in and we look at this, we can see, we'll look at the DDE interpreter one first. And so basically this is looking again at, an Office product essentially trying to launch PowerShell or Command EXE or whatever. And we do see, for example, here, Microsoft Excel attempting to launch Command EXE. And Command EXE, you'll actually get to see the actual command that was trying to be downloaded using the IQY. And remember that the IQY attempted to download the 1.dat file. So this detected this. It stored the evidence here for you to review later, but it also successfully terminated the process. And then Microsoft Excel was also successfully terminated because we told the system to respond by terminating the process and essentially the process tree that was there based upon the detection. We can look at the one-liner ML. And again, we have similar concept here. We have Excel launching Command EXE. Again, with this command, the ML rule also saw this command being bad. And unfortunately, it failed to terminate the process because basically the process was already dead. So the very first rule hit, the DDE rule hit, actually terminated Command EXE and Excel EXE. So while this rule was configured basically to also respond by terminating the process, it was unable to because the process essentially was already gone. So the PowerShell rule here as well. This one did, because we actually had Command EXE launched PowerShell, because of this command here, you can actually see this one because we're using the standard kind of new object web client download string. Pretty darn easy to tell that this is actually going out there and doing a PowerShell download. So basically you can see here that the rule is built looking for very specific strings in the output. Again, this one was able to kill the PowerShell EXE process, and basically the combination of all of these things happening in the background terminated that attack from actually succeeding. So let's switch back to our endpoint system, and then let's try the same thing with our resume. Now, we've got our resume that's here on the desktop, and this is the one, basically the quote original one that we started off with the enable macros, yellow warning, just like we always would get. And if we hit enable content, we properly get our fields updated just like we would expect to with this valid macro. Now let's go grab the one that we put in our Dropbox. And the Dropbox one, where we replace the existing one, is the one where we implemented that macro VB script into this document that is actually now different, and it's going to execute that code that we encoded into Base64 and put into the comments field. So let's go ahead and launch this file. And very quickly here, again, you're going to see that script control is actually stepping in and stopping that macro from executing, which is good. It's exactly what it's supposed to do, and it's supposed to do that. So there's one thing I would love to do really quickly here. I would love to go and turn off. So this is using a standard demo policy that's got all the stuff turned on. What I actually want to do is I'm going to go to this system, and we're going to put it into a policy group whereby script control is actually turned off. So we're going to turn off script control, and we're going to see what optics is able to see if we do actually allow these scripts to attempt to run. So let's check for our policy update. And we'll check our about box and make sure, yep, we've got our script control off policy. So now script control is in a kind of audit only mode, meaning it's going to potentially see the script run, but it's not going to stop it. So it's probably going to just alert on it. So let's try our resume again. All right. So in this case, we actually saw the script attempt to run. You can see down here in the script control that it detected a malicious macro script, but again, it didn't block it as it did before. And we actually allowed Cylance Optics to come in and do the actual detection. And as you see here, just like with Microsoft Excel, Microsoft Word actually just closed because we've actually told it to kill all the processes associated with that stream of events, and thereby protecting the system from being compromised. So once again, we'll flip back to our console. We'll come back in here and we'll get to see, once again, we've got, quite a few hits here. We've got the script interpreter trying to be launched from Microsoft Word. And then, of course, we have the PowerShell or the one-liner command that came in, and we can see that actual command that was attempted. The computer gets to see it as non-obfuscated, Base64. So, it gets to actually see the attempt to run that. So that evidence is captured for you, not just the Base64 string, but the actual command that was attempted to be executed. And again, here you can see, Word launched PowerShell, and by that behavior and that command that was being attempted, those processes were successfully terminated and the system is not compromised. So that's very quickly how basically Cylance Protect, Cylance Optics, all that Cylance technology on that endpoint is defending against those types of attacks, fileless as well as file-based attacks. But whether it's a obfuscated command or anything else like that, it's very easy for Cylance to actually stop and prevent that type of event from occurring. So, okay, that's about it for us seeing how Cylance does. And if you have questions, please do enter them in. Couple of questions around how does Cylance, scan files, for example. Does it scan them as they're being received or whatever? So Cylance Protect, as it scans, executable type files, has two capabilities. It has what's called background threat detection, and it has what's called file watcher. So background threat detection is something that runs slow and slow in the background when you first install the product, and it looks at every file and every process for malicious information. If it finds some, it quarantines it. File watcher is kind of what you were asking there, Chris, is as you receive a file or put it on, copy it over or whatever, it queues it up for a scan in the background. If you immediately attempted to execute the file before that file was scanned in the background, if you attempt to execute it, it will pick it up with pre-execution. So if you, or a process like PSExec or something else, attempts to execute it, then you will, it will be, quote, scanned by Cylance. Now, Optics doesn't actually scan anything. It is our detect and prevent type product, where it is detecting things that are happening real time in memory, as well as commands that are being issued and behavior of applications and things like that. So it's EDR, but it's EDR with a prevention first strategy backing it. So it's designed to stop the bad things from happening, and then you get all of the good evidence that goes into your console to be looked at. And I don't know what's going on with my demo rig today. I apologize for that, but for some reason it's not functioning properly. So I will spend the rest of the day debugging that and figuring that out for our next webinar. But if there are any more questions, please feel free to enter them into the Q&A. I'd be happy to answer them. Would love to answer them for you. I think we've covered most of the questions that are in there. Yeah, so if the threat is not stopped by Cylance, if it's not a pre-execution threat or something like that, the Optics is an EDR. So it is a flight data recorder. It's going to record all of the things that happen. So network connections, files created, all that kind of stuff. is available to be there to actually stop that. And just really quickly, what I can do is I can kind of show you what that looks like. So if you look at the detection rules that are in here, let's say we look at a bunch of MITRE ones, for example. So an Office DDE document, we can monitor for it, and then we can actually take a real-time response, not just upload it to the cloud or anything else like that and wait for humans, but we can actually take a proactive prevention technique and stop the processes. So that's what I was doing here, was I configure it to terminate the process, any children processes that have happened, and pop up a notification window. We could also log off users. We can dump the detection to the local disk, and we can even then respond with an entire playbook of responses. Let's say we want to upload some commands. We want to upload a script, execute some commands, gather some data, and throw it off into an Amazon S3 bucket if you want, for data collection, for evidence collection. All of that becomes available with optics, not just the flight data recording, but actually the actual prevention of the attack, and then based upon the evidence there. So yes, we have some what we call EDR only systems in the demo environment, where we execute malware and watch what optics can see. It's kind of fun to play. It's a good playground. So okay, we are at the top of the hour, and I do appreciate everybody hanging out with us today, learning about how fileless attacks are created. I did want to provide you, here is my contact information. Feel free to take a screen cap of that, or you're going to get a copy of this deck as well. So please feel free to reach out to me directly, and I would be happy to send you those text files that have the PowerShell commands and things like that. Obviously, there are some other back-end requirements that you're going to need to set the the Kali server with Trevor and all the other kind of stuff. But be happy to help you guys set up your kind of own hacking, exposed, virus testing lab kind of stuff. Definitely like helping folks do that. So please feel free to reach out to me, and I will be available to help you and work through those. But thank you very, very much. I really appreciate it, and take care and have a great day. Thank you so much.